Lesson 6.5, we're going to graph square root and cube root functions, and we're going to start off by looking at parent functions. So on the left-hand side, we have our square root. Because it's an even root, we can only input a number greater than or equal to 0. So our domain would have to be x is greater than or equal to 0, and the range would also be y is greater than or equal to 0. Looking at this graph, you can see that we're limited to quadrant 1. All right, so let's look at the cube root. So you can do the cube root of negative numbers, positive numbers, etc. So the domain and the range will be all real numbers. We could write it like that, or we could write it as negative infinity to positive infinity, and the same thing for the range. So I have my parent function graphed here, and you see it's snake-like, and it extends into different quadrants. Here I've included a graph with 2 lines. The square root of x, that's my parent function, and that line is this top one. Then we have our 1/2, and then we have the square root of x, and that is this bottom line. And I want you to just check out the steepness. The blue line, the parent function, is steeper, so the value that's in front of the radical will control the steepness of the line. You might think of it as stretched versus compressed. Now we're going to make a table of values so you can see how we would even get this without a calculator. So because we have an even root, we know that underneath the radical has to be 0 or greater. So I'm going to choose an x value of 0, and 0 times 1/2 would be 0. If I choose something like 1, the square root of 1 is 1. 1 times 1/2 is 1/2. And I'll choose one more value, 4, because we can do that in our head. The square root of 4 is 2, and 2 times 1/2 is 1. And then you would just plot those points. So you can see my points on the graph, and they fit quite nicely. We're going to try another. So now we're working with the form y equals a square root x minus h plus k. And this should look familiar. All right, so first of all, here's my beginning equation, and I used a table of values. I started over here where I inputted a 3 because I knew, because it's an even root, underneath the radical had to be 0 or greater. So 0 times 5 is 0, add the 4, we ended up with the ordered pair 3, 4. Then I inputted a 4, and my output was the 9. And then when I inputted a 7, I ended up getting my y as 14. You could also see when I did it on the calculator, we have the same ones. We have 3, 4, 4, 9, 7, 14. Notice these errors. The errors are because we couldn't include the 1 and the 2 underneath the radical, because then we would end up with a value that was less than 0. This h, which is a 3 here, it says we're going right 3, and the 4, the k, says that we're going up 4. You should remember that from a previous chapter as well. All right, so now we're going to write the domain and range. So based on my table of values, we can see that the domain is x is greater than or equal to 3. So our starting point is 3, but it can go to infinity. And the range is y is greater than or equal to 4, and that also can go to infinity. This graph over here, I have the equation that we already looked at, but now we're going to look at what if we put a negative in front of it. And you'll see that the graph actually is flipped. Cube roots are a little easier because there's no origination point like there is with a square root, so we know that the domain is going to be all real numbers, or we can say negative infinity to infinity, and the same thing for the range, all real numbers, or we could say negative infinity to infinity. Remember that this value says that we're moving right 3, and this value says we're moving up 1. If I had a negative in front, that means the graph would be flipped. And if I have like a 5 or a 7 or a 9 in front, the graph will be stretched, versus if it was a fraction, it would be compressed. Last thing, a graph of a cube root is going to look snake-like. That's not the graph of perfect graph of this particular equation, but it looks snake-like. In this last part of the lesson, we're going to graph and translate a cube root function. You can graph and translate a square root function. It's the same thing. Your domain, remember, is going to have restrictions, unlike our cube. So if you remember from geometry, translation is just a shift up or down, left or right. All right, the very first thing we're going to do is we're not going to do anything with the h and k. So we have our 3 and then the cube root of x. Because it's a cube root, underneath the radical, it's okay if I have a negative value. So if I had a negative 1, I'm going to end up taking out a negative 1, and negative 1 times 3 is negative 3. Of course, 0 is going to yield 0, 0, and then if I put in a 1 for x, out comes a positive 3. So now we're going to graph those. I only have 3 points, but we know that a cube is going to look snake-like, so it might look something like this. All right, the next step, now we're going to consider the h and k. So the translation says, because of the plus 4, we're going to go left 4, and then the minus 1 says we're going to go down 1. So that's like a negative 1, and this would be like a negative 4 if I were inputting it or including it with these values. So if I do that, the x becomes negative 5, the y becomes negative 4. If I say negative 4 and 0, that's negative 4. Negative 1 and 0 is negative 1. And then negative 4 and 1 is negative 3. And negative 1 and 3 is 2. Now we're going to plot those. Okay, so we're going to connect our points in a snake-like manner. Something like this, not quite. So we translated it, we moved it up and over, or down and over. So our domain and our range for this particular problem is going to be all real numbers.